Hi viewers, I welcome you all for this digital system design lecture series. Today we are going to discuss about the topic carry look ahead adder, otherwise called as fast adder. So what is a carry look ahead adder? A carry look ahead adder it is an electronic adder used for binary addition. Due to the quick additions performed, it is also known as fast adder. So this carry look ahead addition logic uses the concept of carry generate and carry propagate. So this carry look ahead addition is the successor of the ripple carry adder. So next one is why do we use? What's the need for a carry look ahead adder? So in parallel adders, we can perform the addition operation when both values required to perform the addition, that is the agent and the addend are present at the same time. So to begin with, we are going to consider a 4-bit ripple carry adder. See here in this, the agent and the addend are readily available. So we know that a full adder can't generate the sum and carry of the respective block unless the input carry is known, because a full adder will be having 3 inputs. Suppose if we are giving agent and add, it will be waiting for the input carry also. So for each and every bit it is waiting for the input carry. So it is producing 30 nanoseconds delay for each and every bit. Suppose if we are using 4 bit means altogether 4 3s are 12. 120 nanoseconds delay will be occurred. Okay. So for an example, see here. Suppose if I am adding A0 and B0. While adding these two numbers, I will be producing the sum term and carry term. So for this carry, the second bit will be waiting. Then I am adding A1 and B1. The output will be S1 and the carry will be produced. For that carry, the next bit will be waiting. See here, I have taken 6 and 13, the binary numbers. So the binary number of 6 is 0110 and 13 is 1101. Okay, so 0110 is the binary number of 6 and 13 binary number is 1101. Okay, while adding I am going to add these two bits. Okay, 0, see here, 0 and 1. 0 plus 1 is 1. While adding these two values, this second and this is second, this orange color, and again this blue color and this orange color, these bits will be waiting. Okay, so again I am going to add 1 plus 0. 1 plus 0 is 1. So the sum will be 1. The next term will be waiting for the input carry. The next one is 1 plus 1, 10. 10 is 0, balance 1. So the last term will be waiting for the carry input. So each and every term is producing 30 nanoseconds delay. So overall it will be 120 nanoseconds. So the total time required to perform addition of 4 bit is 120 nanoseconds. To speed up this process by eliminating the interstage carry delay, this carry look ahead adder was designed. Okay. This method utilizes the logic gates to look at the lower order bits for agent and higher order bits for addend is to be generated. So in this carry look ahead adder uses two functions. As I have told you already, it uses two functions. One is carry generate, another one is carry propagate. So we are going to consider a full adder circuit. Okay. In that full adder circuit, we are going to define these two functions. One is carry generate as Gi and carry propagate as Pi. The equation for Gi is Ai into Bi. It is nothing but the product term, that is multiplication of A and B. And this carry propagate term Pi is expressed as Ai XOR Bi. Okay. The next one is the sum and output the sum output and the carry output will be there. Okay, this sum output and carry output can be expressed in terms of carry generate and carry propagate. So the sum equation will be equal to pi xor ci, pi xor ci, and ci plus 1 is equal to gi plus pi ci. Okay, so see this expression, ci plus 1 is equal to gi plus pi into ci. Okay, so this is the full adder circuit what we have considered. In this only we have defined the two functions, carry generate and carry propagate. Okay, and we are going to find out this ci plus 1. See here, this carry output boolean function of each stage in a 4-stage carry look-ahead adder can be expressed as. Now we are going to consider the equation ci plus 1 is equal to gi plus pi ci. In that, I am going to substitute the value of I value. I am going to substitute first I is equal to 0. That means ci plus 1, I value is 0, so 0 plus 1, which will be equal to g0 plus p0 into c0. That means see here, 0 plus 1, 1. So c1 is equal to g0 plus p0 c0. Similarly, I am going to derive for 4 bit. That means I is equal to 0, I is equal to 1, I is equal to 2, then I is equal to 3. So altogether I have got 4 expressions, C1, C2, C3 and C4. From the above Boolean equations we can observe that C4 does not have to wait for C3 and C2 to propagate, but actually C4 is propagated at the same time as C3 and C2. Then the Boolean expression for each carry output is the sum of product. So these can be implemented with one level of AND gate followed by an OR gate. Okay. Similarly, we can implement the 3 Boolean functions for each carry output C2, C3 and C4. Okay. We can show, I'll show you how the implementation can be done. So see here, for implementation of C1, I have given the diagram. So G0 plus P0 into C0. For P0 into C0, I have used AND gate since it is in multiplication. Okay. So the output will be P0 into C0. So that will be passed as input to the OR gate. Then another one input is G0. So what will be the answer for C1? C1 is equal to G0 plus P0 C0. Okay. Similarly, we can implement it for C2, C3 and C4. Okay. See here, the total number of gates required to implement the carry generator or nearly 10 AND gates we will be using for adding 4-bit numbers. Similarly, we will be having 4 OR gates for adding this 4-bit numbers. So 10 AND gate and 4 OR gate we will be using, right? So next one is advantages. What are the advantages and disadvantages of this carry look ahead adder? So the advantages are nothing but the propagation delay is reduced. The second point is the carry look ahead adder generates the carry in for each full adder simultaneously by using simplified equations involving in Pi, Gi and Cin. It is the fastest adder when compared to other addition mechanisms. So these are all the 3 advantages of this carry look ahead adder. And there are some disadvantages also. So this carry look ahead adder circuit gets more complicated as the number of variable increases. So next one is the circuit for a carry look ahead adder is expensive as it involves more hardware. So since it is complicated and it involving more hardware, these are said to be the disadvantages of this carry look ahead adder. So we have discussed about the carry look ahead adder and advantages and disadvantages. Thank you for watching.